Here's an example of how we utilize static and dynamic compliance and monitor it on a ventilator. As you can see here, this ventilator is providing 600 milliliters of tidal volume 10 times per minute. This is the breath rate, this is the tidal volume setting. The pressure generated to deliver this 600 milliliters is 18 centimeters of water pressure. That's the PIP, peak inspiratory pressure. So it takes 18 centimeters of water pressure to deliver 600 milliliters. So we would take 600 and divide it by the PIP, which is 18, and then we would subtract the PIP of 5 that is on the patient in order to get the dynamic compliance. To get the plateau pressure, I would have to put an inspiratory hold on when the patient takes a breath. And so I'll do that now. And you see a plateau pressure of 15. That showed fairly quickly. P-plat, that's the plateau pressure of 15. So we would take our tidal volume of 600 and divide it by the plateau pressure of 15 and subtract the PIP of 5 from that to get our static compliance. And we would trend that. So I want you to remember that our PIPs, our static plateau pressures were 15, and then let's get back to our PIPs. PIPs are 18, so plateau pressures are 15, and PIPs are 18. Over here is the test lung. The spring that's holding down the bellows here represents the tension on the alveoli. And in the circuit, I have what we call a resistor, and the size of that resistor is about this big. And you can see the hole there. Alright, so this plus this spring right now requires 18 centimeters of water pressure to deliver 600 milliliters of a breath. I'm going to change the size of this resistor right now to this size resistor. See the very small radius? So you would expect that the pressure to ventilate this test lung will be much higher once I make this change. The ventilator is alarming because I've disconnected the patient. With the new resistor in place, the airways are much smaller, therefore the peak inspiratory pressures to ventilate this patient, 600 milliliters, are now much higher. And you can see they're rising with each breath as the patient is beginning to air trap. And we talked about air trapping. So the PIPs have gone significantly up, but let's do the plateau pressure. $15 again. I know that went by quick, but the plateau pressures stayed 15, but the peak inspiratory pressures are very high now. Let's get back to that. Find that spot. 51. So PIPs increased significantly, plateaus stayed the same. The problem is in the airways. The resistor I put in represents what happens to the airways when the airways resistance increases and the airway diameter decreases.